Hello everyone, this is Jeffrey Souza of the Madwick team for UMass Dartmouth. We're working on this project for our senior capstone. And one of the main reasons we're working on this project is due to the Madwick competition that's currently taking place, the MECC, which is funded by the U.S. Department of Energy. And it's overall trying to find more reliable, cleaner energy sources, and we're looking towards the ocean for that in this case. Last year's team was the first year of this overall competition. They ended up second place in the overall design of the Madwick device and also won the overall prize for the business post that was created, which you see here on your left. We have multiple different people working on this project: mechanical engineering, electrical engineering students. We also have a graduate student from last year's group that has come back to help us, along with some faculty advisors. We're going to have some business and marketing people to work on a marketing plan later on in the competition. And also we have an illustrator that will help us draw the Madwick in different places. We have two main colleges that are working with us on this project: the College of Business and also the UMass team, Marine Science and Technology, that is helping us by giving us a place that we can actually work on this system in general. The overall design is rather simple when you think about it and when you learn about these things. We have a system where there are ballasts below the system. You see them as little squares in this picture. When the waves go down, those ballasts will open, which will allow energy to be moved through the system. And then when the wave goes up, you will then have those closed so that we do not have energy being created by the downstroke of the wave, but then dispelled by the upstroke. So we're making sure that this energy is just going to be created and stored there in batteries down the system. Right now we're working on the build and test competition portion of the MECC competition, and that is being done at the UMass campus. We're currently getting our parts in to build our testing rig as well as build the actual power takeoff unit, which is the main part of the Madwick device that will create the energy from the waves and convert that down into batteries. Here's a small video from SolidWorks made by last year's group. The top is the main reel, which will then be moved down to this torsional spring, which will rotate with the waves. We have a slip clutch in there to make sure that it only rotates one direction. So like I said, we do not have it creating energy then dispelling energy. The bottom there are the generators, which will make that rotational energy turn into electrical energy, which will then be stored down in battery packages for different devices to use. I'm going to throw it down to Cameron, who is down in the lab currently right now, and he will explain to you and show you some of these components in real life as well. Thank you for listening.
I'm Cameron Jasparrow. I'm a senior mechanical engineer at UMass Dartmouth, and this is our capstone project for our senior design. First, we're going to start presenting our winch and then how it works. Basically stated beforehand, this winch will act as the buoy as it goes up and down the wave, translating this linear motion, and this rope will be attached to a reel. This linear motion will go through the reel, and then the reel will translate that to rotational motion. The reel will then be attached to this spring, and this rotates the spring, tracing torsion in the spring, which would then turn this shaft. This shaft is attached to this slip clutch. This slip clutch is so that we don't over torque the entire system. So after a certain amount of torque is applied to the system, this slip clutch will release and then nothing will be generated. This slip clutch will be connected to this another shaft, which has a one-way clutch into it. This clutch will go into here, but the purpose of this one-way clutch is so as the Madwick system goes up the wave, this will turn to produce power. And then as it goes down the wave, this will go back this way, which won't produce anything. So essentially the whole reason for this is to make it so the Madwick produces energy as it goes up the wave. This planetary gearbox is so that it converts this hard motion, rotational motion, into a much faster rotational motion. And then this is a clutch to hold the planetary gearbox and the shaft together. And this gear is attached to this shaft, which will drive these three generators, and as this one-way clutch is moving, this gear starts to turn, which in turn will turn these generators and then produce power, which will be attached to batteries. Now, all those components I just explained will be put into this PVC housing when we move to a wet test. However, we're doing a dry test at the moment to understand that our design is working as last year's team created it. And this is our entire design for our Mad White project. Thank you.